Hey everybody, today we're going to work on session 2 again of 2015 Mcas. We'll see if we can get through this. I don't know, we'll see, there's quite a few open response questions I think, so there's 1, 2, we'll see if we can get through this before the end of my prep here. So the PDF for this is located in the video description, so you can download that, try this out first, and then you'd watch this video, see how you did. This is the calculator section because it's session 2. So if you have a calculator, you can use one of those. Okay, so let's get right into it. The table below shows the number of students enrolled in different science classes at a high school. So here we go. We have biology, environmental science, earth science, physics, and it looks like chemistry is empty. And these are all the numbers of students in each of those classes. So there are a total of 1,200 students enrolled in science classes at the high school. I'm surprised they didn't name it. Each student is enrolled in only one class. What is the total number of students enrolled in the chemistry class? Okay, so we know all these added together will equal 1,200. So what we can do is add these up and subtract this from 1,200. That should give us the difference, which will be the chemistry students. So let's go ahead and figure that out. So we have part A. We're going to add these all together. So 240 plus 285 plus 300 plus 195. And we're going to use a calculator for that. Why not? 240 plus 285 plus 300 plus 195. Now when you're doing something like this, it's really easy to make a computational error. So what I recommend is adding these together twice, just to make sure you didn't make a computational error. So we got 1,200, but again, let's just double check that just to be safe. So we're at 1,200 for now. Sorry, 1,020. 1,020. Let's see if that works again. So cancel this 240 plus 285 plus 300 plus 195, and that gives us 1,020. So that's how many students are that are in these other courses. So we're going to subtract. This value 1,020 from the total, which is 1,200. So 1,200 take away 1,020, and that's going to be equal to 180 students. Okay, and that's how many are in chemistry. 180 students. Okay, so far so good. Part B, what percent of the total number of students enrolled in the science classes are in chemistry? So now we want to know what percentage 180 is out of 1,200. So in order to do that, it's pretty straightforward. We're going to take 180, which is the number of kids in chemistry, and put that over the total, which is 1,200, and multiply that number by 100. Okay, so let's figure this out. So 180, actually we can simplify this. So let's cancel 18 over 120. So 18 over 120 is that. Multiply that by 100. So 1,500 times 100 equals 15%. Okay, so it's 15% right here. Okay, let's scroll down a little bit. A guidance counselor at the high school made a circle graph based on the information in the table. The central angle of one sector of the circle graph measures 90 degrees. Which science class is represented by the sector of the circle graph that has a central angle of 90 degrees? So this is a very interesting problem. Okay, so the way this works, I'm going to draw an example here. So here's our circle graph. So they're saying that the central angle has 90 degrees. Okay? So that means it's going to take up 1/4 of this. Let's say we didn't know that. So you take the degree, which is 90, have it over 360, multiply that by 100, and that'll give us the percentage, right? Which is going to be 25%, because 90 degrees is 25% of 360. But if you didn't know, let's say they did like 70 degrees or something that wasn't as easy as 90, this is how you would figure out the percentage. So we're looking for a class that's 25% of the total number of students. So what we're going to do is find out the percentage of all of these. So we know this is was it 15? 15%. So we don't need to find all of them. We just need to find the one that's 25%. So we know it's going to be significantly higher than 180. So that's not high enough. That might be too high. So let's try one of these. Let's try 240 and 285. Let's try 240. So 240 over 1,200 times 100. So I'm going to skip the whole simplification step because I think that might just confuse people. So we're going to divide this, so 240, and this is bio. 240 divided by 1,200 times 100, it's going to be 20%. So it's not quite high enough. So it has to be one of these two. Let's try 285. So 285 is environmental. So 285 over 1,200 times 100. Let's see what that is. So 285 divided by 1,200. It's not quite high enough, so it's going to be the other one. So 23 3/4. So 23 3/4%. So 23.75%. So it has to be 300, but let's just make sure. So this is going to be earth science. So 300, yeah, that makes sense because look, it's going to be 1/4 of that. We know 300 divides that 4 times. It's 300 divided by 1,200 times 100, 25, yep. That makes sense. So there we go. And I believe it's asking us for the class. Let's see. Which science? Yeah, which science class? So it's going to be earth science. So really this problem, the first part was just subtraction, and the next two is just, do you know how to work with percentages? Part D, what is the degree measure of the central angle of the sector of the circle graph that represents the number of students in bio class? Okay, so now it's kind of like reversed here. All right, so let me get another piece of paper. So part D, bio we know is 20%, all right? So 20%. And we don't know what the degree is, so we're looking for that, x. And let's change this to a decimal. So 0.20 equals x over 360 degrees. So this will be the angle we're looking for, over 360. And we already know bio's percentage. So because we found that earlier, we can use that. So we're going to cross multiply. Well, we're going to multiply by 360. We're not cross multiplying really. You can think of it that way if you want to, but you're really not doing it. And then, so 360 times 0.20, 72 degrees. And that would be the central angle of the degree measure of the sector. Yeah, 72 degrees. Okay. So hopefully that explains number 36. This is really just a percentage problem. Do you know how percentages work and how to work with them? So, okay, that's number 36. 37. Zoom in a little bit here. The diagram below shows a trapezoid and its measurements. The trapezoid has an area of 60 centimeters. What is the value of x? We're trying to find out what that is. Let's look at the area formula for trapezoid, which is right here. So the area of a trapezoid is right here. I'm going to write this down. So it's area equals 1/2 height times the sum of the two bases, B1 and B2. So this is B1. It doesn't really matter. This is B2, and this is the H. So and we're given the A. So A equals 1/2 height times the sum of the two bases. Okay, let's plug these numbers in. A equals, A is actually 60. We have that one. 1/2. The height is 6. B1 is 6. B2 we don't know. So we have to solve for this B2 that's in the parentheses. Okay, we can do that. Let's multiply these two together first. So 1/2 of 6 is 3. So 60 equals 3. 6 plus B2. We're going to divide both sides by 3. Those cancel. I'm going to have to rewrite this over here. I'll write it over here. So 60 divided by 3 is 20. And then we're going to have 6 plus b squared, B2. And then we're going to subtract both sides by 6. So B sub 2 is actually 14 centimeters, which is right here. Okay. So this just required you know how to use the formula on the sheet. Number 38, a right circular cone has a volume of 39 cubic inches and a radius of 2.5 inches. Which of the following is closest to, so we're estimating here, the height of the cone. So we're talking about volume of a cone. Let's find that formula here. So volume of a cone. Oh, did I do that? Yeah, okay. I just got myself confused there for a second. Okay. Volume of a cone. Volume of a cone right here. So V equals 1/3 times pi r squared h. Okay. So V equals pi r squared h. The volume is 39 cubic inches. The radius is 2.5. And we don't know what the height is. So we're solving for that. So because we're estimating, we're going to plug in 3.14 for pi, because you'll notice pi is not part of the solution here. So 39 equals 3.14 times, this should be squared, 2.5 squared times h. All right, let's figure this out. So first we got to do exponents, so we're going to do that part. So 2.5 times itself, 2.5, 6.25. So 39 equals 3.14 times 6.25 times h. Now we're going to multiply these together. So 6.25 times 3.14. We're going to get that ugly number. So 39 equals 19.625 times h. And now we're going to divide both sides by the coefficient, which is 19 in this thing. There we go. 625 thousandths. That's a fun word to do, huh? Fun number to do, rather. So 39 divided by 19.625. So it's very close to 2. Huh. Did we screw up here? What is the closest to the volume? So this is, something went wrong here. Let me pause this for a second. Well, I'll tell you what went wrong. Look at this. Which formula did I use? Did I use the right circular cone formula? I sure as heck did not. I used the right circular cylinder. You know why I did that? Because I circled it earlier when I was doing another problem, and that circle actually drew my attention to it. It's actually this one. I was like, what are we doing wrong here? Because all our math is correct. I used the wrong formula. So it's okay to make mistakes. Let's do it right. But at least you can see how not to do it. So there we go. So V equals 1/3 pi r squared h. Okay, same way though. So 39 equals, we're going to run out of room. That's okay. 1/3. And again, we're going to do 3.14. Pi, we did that. R is going to be 2.5 squared h. Okay, so 39 equals 1/3 3.14. And we know 2.5 is going to be 6.25. And now we're just going to get this all together and then divide 39 by it. Okay, so here we go. So 1/3 times that. So it's the same as dividing this by 3. So let's go ahead and do that. Okay, so 3.14. 3.14 divided by 3, which is the same as multiplying by a third, gives us this. I'm going to just multiply this. I'm not going to write this all up because we're going to lose decimal spaces, so it'll be easier if I just do it like this way. Times 6.25 equals that. So we are going to round that. We're going to say 39 equals 6.542h. We're going to round that to 2. And then we're going to divide both sides by that. 6.542. 6.542. Okay. And then 39 divided by that. So 39 divided by 6.542. So it's very close to 6. It's very, very close to 6. So C should be the answer. So I apologize for getting anybody confused. They're like, what's he doing? I used the wrong formula. Wah, wah. Okay. Let's take a look at number 39 here. A computer software package is sold to small business clients. The total cost of the software package is $500 to the first 10 computers on which the software is installed, plus $20 for installation on each additional computer. Which statement best describes the function that models the relationship between the number of computers on which the software is installed and the cost of the software? Okay. So first 10 it costs you $500, and then it's $20 for each additional computer. So this is a linear equation, right? It's a linear function. All right, so here we go. It is a constant linear function for 10 or fewer computers, and an exponential function. No, there's no point in which this is exponential, so that's out. It's an increasing linear function for 10 or fewer computers, and no, it's not an exponential function at any point. It is a constant linear function for 10 or fewer computers, and an increasing linear function. Yeah, that's exactly what it is. Constant means it's going to be, this is what's the rate of change is flat, and then it goes up after one point, at which point is after 10 computers. That sounds about right, increasing after that 10th computer. An increasing linear function for 10 or fewer than constant, no. So this makes it sound like it goes up slowly, then taps out. That's not exactly what happens. This one's out. So it's constant for the first 10 because you pay a flat fee, right? $500. So that doesn't change. Then once you get to the 11th computer, you start adding $20 each time. So it would definitely be constant followed by increasing. So this is really requiring you to know what those words mean, right? Constant and increasing in terms of linear equations. Okay. We're going longer than I meant to, but we're gonna power through this. Yeah. Here we go. I think we'll be able to finish it in time. A parallelogram is graphed on the coordinate grid below. This parallelogram will be rotated 9 degrees clockwise about the origin. Which of the following shows the location of the parallelogram after the rotation? So there are some rotational rules that you're expected to remember. However, you don't need to do that when you have a problem like this. It's a really cheap and easy way to do this. So 9 degrees clockwise, which means clockwise is going this way. So you're going to be going this way 90 degrees. Well, take your paper and rotate it 90 degrees that direction. That's what the image is going to be, just like that. So when I turn this back, see if anything looks like that. I see two that are like that. I have one here and one here. So the difference is this is going down, this is going up. Let's see. It's going down. Has to be that one. So you immediately are able to eliminate the other two. So yeah, it's a real simple way to do that. If they say 90 degrees, you can literally just rotate it 90 degrees the direction you need and you can see it. So very, very easy way to get that correct. Okay. Number 41. There's two left. Let's see if I have some scrap paper for this one. Here we go. Okay, number 41. The expression below can be used to calculate the balance in the savings account for which an initial deposit of P dollars has been compounded each year for T years at an interest rate of R. P equals parentheses 1 plus R over T, to the T power. Okay. Okay, Elaine opened a savings account with a deposit of $1,000. The interest on her account is compounded each year at a rate of 2%. Elaine will not make any additional deposits to or withdrawals from her account. Okay? What will the balance in Elaine's account be at the end of year one? So let's go ahead and take a look at this. So part A, I'm going to use this formula. So P is the principal, R is the rate as a decimal, and T is the time, annual time. So in terms of years. So P, our principal is going to be 1,000. And then our rate is going to be 2%, so we're going to convert that to a decimal, so it's 0.02. And T is going to be 1 because it's 1 year. It's an annual account. It's an annual interest rate, I believe, right? Yeah, compounded annually. Okay, so 1. So let's go ahead and follow order of operations. So this happens first. So we're going to have 1,000. Hey, what's going on? 1.02 to the 1 power. This to the 1 power is going to stay the same. So we're going to say 1,000 times 1.02. Now we're going to multiply these together. So we're going to move this, let's see, 3 zeros, so 3 spaces. So 1, 0, 2, 0. So there we go. So what's the balance? 1,020. So basically Elaine earned $20 over the course of a year. Not bad at all. All right, part B. What will the balance in Elaine's account be at the end of 3 years? All right, well, same thing. We're just going to change T to 3. So 1,000. And then 1 plus 0.2 and the 3rd power. Okay, so 1,000 plus 1/200. And now we have to do that to the third power, so we're going to say, okay. So 1.02 times 1.02 times 1.02. And that's going to be that times 1,000. I'm gonna not write that down because I won't lose any decimals. Times 1,000. So okay, we're gonna have to round this. So $1,061.21. I'm rounding that to 1. So that's the pennies column. Okay, so that's part B. Part C. Pavel opened a savings account with a deposit of $800. The interest on his account is compounded each year at a rate of 2.5%. Pavel will not make any deposits. Okay, so it's a little different account, different rules. Whose account, Elaine's or Pavel's, will have earned more interest? Who will earn more interest at the end of 3 years? So this interest was $61.21 because she put in $1,000. So this is her interest after 3 years. So this is Elaine's. We already have that, so we have to figure out what the interest for Pavel will be. Okay, so P1 plus R to T power. Okay, so his principal is $800. So his initial deposit is less, but his rate is higher, 2.5%, so 0.025, and then 3 for time. Okay, so 800 times 1.025. Should be a plus sign there. Whoops. 1.025. Yep. It's a third power, so let's figure what that is. So 1.025 times 1.025 times 1.025 equals, and I don't want to write that down because I want to keep it as accurate as I can and multiply that by 800, so times 800. So, okay, he's got $861.51. Okay, so his principal was 800, so subtract 800 from this and you get 61.51. That's his interest. All right, this is where people screw this one up, I think, because they look at this and they say, okay, her number is higher, therefore she earned more money, but she really didn't. He actually has 30 cents more that he earned because they're asking specifically for the interest, so it's the difference between the principal and the new amount. So Pavel actually earned more. So Pavel earned more there. 30 cents more. I mean, it's pretty, not a whole lot more. More than Elaine. Okay, last part. I need some more scrap paper, I think. See, is this some? Yeah, I guess I will. Okay, part D. Oh, there's no part D. All right, cool. Never mind. All right, that's not too bad. Last one. Here we go. Here we go. All right, let's zoom out a little bit so you can see the whole thing. Parallel lines Q and M are cut by transversals J and K. So these are parallel, Q and M. I'm going to go ahead and show that. Transversals J and K. The lines and the measures of some of the angles created by intersection lines are shown below. So we're given some of the information here. Okay. What is the measure in degrees of angle 1? So we're looking for this one. Well, we can do that really easily because we know these are supplementary angles, which means they add up to 180 degrees. So 180 minus 110 is going to tell us, and that's going to be 70 degrees. I'm going to go ahead and write that in there, 70 degrees. What is the degree measure of angle 3? So angle 3 is here. So there's a few ways to do this. Let's go ahead and find this one first, and you'll see why. So these are supplementary. So 180 minus 115 should equal, what, 65 degrees? Yeah. So this is 65 degrees. And the reason I did that is because I know these two angles have to be congruent because they're corresponding. And corresponding angles with parallel lines are congruent. So that means this has to be 65 degrees. So angle 3 is 65 degrees. What is the measure in degrees of angle 5? So angle 5 is here. And again, this is corresponding to that. So if I can find 7, I can find 5. And I can find 7 because, look, this is a triangle. I know this is 70, this is 65. I know all three of these interior angles of a triangle have to add up to 180. So we're going to find that by subtracting these from 180. So 70 plus 65 is, what, 135? And we're going to subtract 135 from 180. And that's going to give us, what, 45? Yep. So this is 45 degrees, which means this corresponding angle would also be 45 degrees. There's the bell. What is the measure in degrees of angle? 6, which is right here. Well, these are vertical angles, so they're actually the same measure, so it's 45 degrees because they're vertical. That's actually not bad for a 4-part problem. I think that's it. Yeah, that's it. Very cool. All right, so we finished 2015. Let's see how we did. I don't think the short answers are going to be given our answers, though, unfortunately. Yeah, they can't. But let's check the ones that were not short answers. So 37, we got B, and B is correct. 38, the one I screwed up. We got C. C is correct. 39, we got C. C is correct. 40, we got A. That's correct. And I think the other two are open response. So guys, I hope that was helpful. I'm going to keep doing these. We're going to keep doing all the old MCASs we're going to do, as well as the most recent one. They released all those problems. I'm going to wait till later in the year as we get closer to May. So I'll probably wait till February or March till we do the more recent one, or maybe I'll do it sooner. We'll see. Hopefully that was helpful. Thanks, guys.